If you are new on this channel and you haven't subscribed, please subscribe and hit that bell icon. At this moment of the day, boys and girls, today I'm going to teach you about quadrilaterals. A quadrilateral is any enclosed four-sided plane shape. Let us look at these shapes. The shape in red is not a quadrilateral because the shape is not enclosed. It has an opening here, though it has four sides. But this one, it is a quadrilateral because all four sides, 1, 2, 3, and 4, they are closed. Right? So let me explain about the properties of quadrilaterals. I'm going to teach you about the properties of a kite, the properties of a trapezium, and I'm also going to explain the concept of an isosceles trapezium. And then after that, I'm going to explain the properties of all parallelograms. The parallelograms includes rectangle, like this one, a rectangle, parallel sides like this, as well as this one. And then from there, I will explain the concept of a general parallelogram, as well as a square and a rhombus, all the properties of these parallelograms. All right. Let me start by explaining the properties of a kite. A kite looks like this, and it has got one line of symmetry, which is this one. And if we fold these to this point, it will align all edges perfectly, forming a new shape like this one. So this is the line of symmetry. All right. Then the diagonals intersect at 90 degrees for a kite. A diagonal is from one vertex point to another vertex point, as well as this vertex point to this one. The point of intersection here, they will intersect at 90 degrees, which is 4 right angles to make 360 in total, which is fine. And then the next property, the shorter diagonal is always bisected, which is divided by 2 if we say bisected. In this case, the line will be divided by 2. This will be halfway, and this is the another half, because the shorter diagonal has been dissected by the longer diagonal. All right. Let me explain about the properties of trapezium. The general trapezium, as well as an isosceles trapezium. I'm going to start by explaining the properties of a general trapezium. Right, a general trapezium looks generally like this, and the main important thing is that a trapezium has got only one pair of parallel sides. In this case, this side is parallel to this one, and we indicate by these arrows to show that they are parallel. Then a general trapezium has got no lines of symmetry, right? Then an isosceles triangle has got a pair of parallel lines. In this case, this line is parallel to this line, and it is indicated by these arrows. And then the remaining opposite sides or the lines, they are equal. So if the opposite sides are equal, it means that it is an isosceles trapezium. And again, it has only one line of symmetry. In this case, the line of symmetry is positioned at this point perfectly. Let me explain about parallelograms. Properties of a rectangle as the first parallelogram. Rectangle has got opposite sides that are parallel. This side is opposite to this one, and they are parallel. And this side is opposite to this one, and they are parallel. Then in option 2, opposite sides are also equal. Both sides are equal, and this one, which is opposite to this other side, they are also equal. That is another property. And then another property, it has 4 right angles. A right angle here, a right angle which is 90 degrees, and a right angle 90 degrees, another right angle which is 90 degrees. Then the diagonals are equal and they bisect each other. This is a diagonal and this is another diagonal. So for a rectangle, the diagonals are equal and equal lengths and they bisect each other. Then the diagonals divide the rectangle either into two right angle triangle like this one. the rectangle into two right angled triangles and four isosceles triangles. The first right angled triangle is this one, and the right angle is at this point. This is the first right angle triangle, and this is the second right angle triangle, which is divided by this diagonal. And again, the four isosceles triangles will be formed by both the diagonals. This is the first isosceles triangle from this point to this, and then this way. And then this is triangle number 2, and then isosceles triangle number 2, which is also equal to the fourth the isosceles triangle. It has got two lines of symmetry. The lines of symmetry, let me explain on a separate diagram. This is the first line of symmetry, and then this one is the second line of symmetry. If we fold the rectangle, all sides will align perfectly. So let me move on and explain the properties of parallelograms. A parallelogram is an umbrella term, so its properties should be universal and should apply to a rectangle, square, and rhombus, since they are all parallelograms. A general parallelogram has got this property: opposite sides are equal and parallel. This side is equal and parallel to this one, and this side is equal and parallel, equal like this, and parallel to this one. I've write two lines like this to show that, to differentiate from the first pair of lines which are equal. Another property: opposite angles are equal. This angle and this one are equal, and this one and the opposite one, they are equal again. Then for all parallelograms, diagonals bisect each other. So in this case, the diagonals, they bisect, and this is the midpoint. I represent it with M. This side will be divided by 2 up to this point, and this one, the other one. And this side will be divided by 2, this part making the first half, and this one making the second half. Each diagonal divides the parallelogram into two equal triangles. In this case, let me explain on a separate diagram. If I draw a diagonal like this, the first triangle, which is this one, I'm marking triangle 1, is equal to this triangle number 2. Then if I draw another diagonal, which is this one, this diagonal, it will also divide the parallelogram into two equal triangles. Triangle 1, which is equal to triangle number 2. All right. So this is about parallelograms. Let me move on and explain the properties of another parallelogram, which is called a square. A square is a parallelogram, but it is called a square because it has got its specific features. But all properties of parallelogram apply. But for it to be a square, all sides, side number 1, 2, and 3, as well as side number 4, they are equal. So it becomes a square. So in addition to the properties of a general parallelogram, for a square, all sides are equal, and it has 4 right angles. Right angle number 1, right angle number 2, and then right angle number 3, as well as right angle number 4. And another property, the diagonals make an angle of 45 degrees with a side. So a diagonal, this diagonal, will make 45 degrees at the side like this, 45 degrees, which means it will bisect the 90-degree angle. And this one is also 45 degrees, and 90-degree angle has been bisected, which means the remaining side is also 45 degrees, and this other again is 45 degrees. So this scenario is the same for this diagonal. All these angles are bisected into 2 to make 45, 45, 45, 45. All right. So this is true for a square. Then it has 4 lines of symmetry. Let me explain the concept of lines of symmetry on a separate diagram. If I cut this square into this line, or by this line, or at this point by this line, or by this way, all edges of this square will align perfectly, as I have explained earlier using a kite. So These are lines of symmetry. In this way, if you fold from this end to this end, it will align perfectly. If you cut it this way, if we align this edge to this edge as well as this edge to this edge, it will align perfectly. As well as this side, this vertex point will align to this one, and this edge will align to this one. So it is another line of symmetry as well as this one. So a square has got 4 lines of symmetry. Taking a short break, coming back soon. Subscribe to our YouTube channel for more, or visit our website mugombionlineschool.com and enroll for a full course. Thank you. It is of a rhombus. A rhombus looks like this shape, and all properties of a parallelogram apply. That is, opposite sides are equal and parallel like this, and again these opposite sides, they are equal. But in this case, for a rhombus, all four sides are equal as a square, and these ones, they are parallel, and opposite angles are also equal, and we indicate by marking the angles like this, and these opposite angles are also equal, and we mark them differently to those ones, indicating that they have a different size. Then in addition to the properties of a parallelogram, it has 2 lines of symmetry, this first line and this second line of symmetry. And apart from this, the diagonals bisect at 90 degrees. This is a diagonal and this is the second diagonal, and they bisect at 90 degrees. Bisect means they divide by 2, which means this is the midpoint, and they bisect at 90 degrees, which forms a right angle here. So all these are the properties of a rhombus. Let's grow this community together. Hit that subscribe button now. It's free. Thank you.